So Jeff, we're in Ynysowen Primary School, which has been built close to the school that was destroyed in the 60s in Aberfan. Do you want to talk a little bit about the effect of the landslide that it's had on the community, from your point of view?
Yeah, well, obviously the tip came down from the colliery waste that was put on from Merthyr Colliery, and it engulfed Pancras Junior School, and I was a pupil in that school at that time, and out of my class of 34 only 4 of us survived. So I've got a real interest in terms of landslides and their effects on the community.
Yeah, and that's exactly the reason that we do the research, is to provide that information, so it's there so that then people can act on it.
Well, the first question I'd like to ask you is, what brought you interest in landslides in the first instance?
Landslides are probably one of the most dramatic processes, and obviously as well they're a devastating hazard. From pretty early on at school I knew about the events at Aberfan and what happened here. We learnt about that, and so both the physical process of why these things happen and also their impacts on society, they both really interested me.
Obviously my interest in landslides is my involvement in the Aberfan disaster and being a survivor of that disaster. So I'm very interested in reading about the work that you're actually doing and the development of the predictive model that you've developed. So how long has it taken you to develop that model?
So this is a model that predicts, or tries to predict, where landslides are likely to occur during big earthquakes. And I've been working on this for about 7-8 years now, working in this area of earthquake-induced landslides, not just on this topic, not just on this problem, but that's how long I've spent working in the field. The model that we've produced, we call it ShakeSlide, takes information from lots of past earthquakes, information on where landslides happened, and based on that information it tries to predict where landslides are likely to occur in earthquakes in the future. And I've been working in that area for about 7 years now, and specifically on producing that model for about 3 or 4 years.
And how does that model you're developing differ from other models of predictive nature that the universities and other parts of the world are developing?
So there's all sorts of aspects of landslides that you can do work to predict and produce models to predict. Some models and some work tries to predict the timing of a landslide, when a hill slope will fail. What we try and do here is we take the earthquake event as a whole and over a very large area try and predict where landslides are likely to have happened. So it's a broad area prediction. I work in a team of geomorphologists, so we're people who study Earth's surface processes, and naturally the interest is how a landscape behaves at the large scale. So the difference is that rather than making predictions for specific locations, will this hill slope fail or not, we want to know what the likelihood is over a large area. And this is useful information in terms of planning for future earthquakes, and also in terms of responding to earthquakes when they happen.
How accurate is the model that you've actually developed?
So in terms of the accuracy, in terms of predicting the precise locations of landslides, there's still a lot of uncertainty in doing that. What we try and do is predict the areas in which landslides are likely to have occurred. And the uncertainty that's there is due to uncertainty in the inputs that go into the model. So we don't necessarily know, or there's uncertainty in understanding the strength of the seismic shaking, the strength of the hill slope materials, and what that means is that predicting the precise slopes that will fail is difficult, but predicting numbers of landslides across an area or along a valley, that sort of thing we can do with more accuracy. There are techniques for, so if we know, for example, that a village is threatened by a landslide, there's lots of approaches that we can apply to do monitoring on that hill slope and look for signs of failure, try and predict whether a landslide will happen and when it will happen. But the work that I'm doing here with ShakeSlide is trying to predict over a large area where landslides are likely to occur.
So any practical examples that you give me in terms of where this model has been adopted and what benefits have been accrued to the communities where these landslides have taken place?
So last year, when the Nepal earthquakes happened, we ran this model kind of in anger for the first time, and we produced a prediction of the spatial pattern of landslides from that earthquake. And we provided that model to the World Bank, who were doing a lot of work in the post-disaster response to the earthquake. It helped them guide the search for where landslides were likely to have occurred. So it helped them understand where landslides were likely to have occurred across that area affected by the earthquake, and guide the search for damage from landslides through satellite imagery. It's difficult to pin down precise examples of where that's had an impact. But we know that our partners at the World Bank, they found it useful in that event to have that information.
And how do you overcome the cultural differences between societies where these landslides occur and their attitude to providing infrastructure to the predictions that you're making?
So this is really quite a challenge, and it's relevant because we're talking about the 50th anniversary of the Aberfan landslide coming up, and that's an example where we were aware, or society was aware, of the dangers of landslides. We knew that landslides could be triggered by rainfall. In fact, the scientific community, the engineering community, had known for about 40 years of the process. They've understood the process of how landslides were triggered by rainfall, but the information wasn't acted on. So it's certainly one of the challenges, is not just producing this information about the physical hazards and understanding landslides, but getting people to use and act on that information. What we're doing at the moment, we're working very closely with the Chinese government and with policymakers in China, and through our project we'll be doing some engagement with them to help them understand how they can best use that information. And for example, if there was a future earthquake, how that information could guide the response and guide planning. A lot of the work I do at the moment looks at the aftermath of a big earthquake, and after we've had a big earthquake in a mountain range, we typically see very high rates of landslides triggered by rainfall that continue for many years. And we're trying to understand how long those landslides go on for, where they occur and why they occur. And if we know that, that can help us understand how to deal with that hazard in the aftermath of future earthquakes.
So what effect then has climate change had on the number of landslides that have actually occurred? Has there been an increase as a result of global climate change?
So across the world, climate change predictions suggest that we could see an increase of around 10% in the number of big rainfall events. That's the prediction from the International Panel on Climate Change. And so the concern is that 10% more rainfall events could lead to many more landslides. And we've done some work on this recently in the Appalachian Mountains in North Carolina, where we've essentially tested that. And we're finding something really interesting, which is that more rainfall events will not necessarily produce many more landslides. Aberfan is actually quite a nice example to understand this. So we know that the landslide at Aberfan was triggered by rainfall, but the cause of the landslide was actually the tipping of mine waste up on the hill slope. If that mine waste hadn't been tipped on the hill slope, then the rainfall event would have happened, but we wouldn't have had a landslide. Now, in natural landscapes, it's soil that accumulates on hill slopes, and it accumulates very slowly through time. So typically it can take thousands to tens of thousands of years for a thickness of soil to accumulate, which can then produce a landslide. In the Appalachian Mountains, where I'm working, we found that the rainfall events, so we have big hurricanes there that produce very heavy rainfall, they're so frequent already that the landscape actually isn't producing soil quick enough to produce more landslides. So if we have more rainfall events... Doesn't necessarily mean there's a landslide. Yeah, it doesn't necessarily mean that we can increase the number of landslides, or there will be more landslides.
So there are a number of factors then in terms of why landslides occur, not necessarily earthquakes, because we may not have a landslide as a result of that earthquake, but it could be the soil mechanics, it could be the precipitation, or a combination of those factors.
Absolutely, yeah, that's right. We know that landslides will continue to be a problem in the future, and certainly in our changing climate we will continue to see landslides. The good news seems to be that we might not see an increase in landslides that's proportional to, say, the increase in the number of rainfall events. As you say, because there's slope mechanics, there's all sorts of other processes that are important in producing those events.
So how do you undertake the monitoring of potential landslides?
So if we've got a village that's threatened by a landslide,
Yes.
and what could you do? So techniques you can use there are to monitor that slope, so to look for signs of movement or creep in that slope, which would indicate that it might be heading towards failure.
So is that by pegging, or is it by satellite imagery, or?
So you can use all sorts of techniques to do it. So certainly, I think even at Aberfan, they were monitoring pegs in the hill slope. They were monitoring movement there. So the simplest and probably cheapest approach is to put some pegs in and monitor the movement with pegs. We can use laser scanners. They're very good at detecting patterns of movement, particularly across a hill slope. We can use radar techniques as well. So they're all different ways of measuring the same thing, but looking for signs of movement.
So what's the impact of changes in technology meant to your research over the last 7 or 8 years? And how has it improved the analysis of the data that you're collecting?
So we've had obviously an incredible increase in the amount of data that's available to carry out analysis of landslides. Probably one of the most important sources of data is detailed 3D models of the Earth's surface. In the last 10 years, we now have 2 3D models of the whole surface of the Earth, and they are really powerful tools that we actually use within ShakeSlide. They tell us how steep hill slopes are everywhere from the UK to China. And so we can carry out stability analysis over very large scales. We also have very detailed data sets as well, which are really very valuable in their own rights. Satellite imagery is incredibly useful. We can use this to capture data on landslides. So if we have a satellite image before an earthquake and satellite images after an earthquake, we can monitor where landslides happen and how those landslides change through time. And also in terms of computer processing, we have the processing power and the machine learning algorithms to process and help us understand this data. This is something that really fascinates me, is how we can use these algorithms, these techniques, to help us predict where landslides will happen, and that's a big part of the work we're doing.
And that information then, is it available only within the academic environment, or is it open to governments, to insurance companies, and obviously the general public as well, who may show an interest in this field?
That information is open to lots of people. So ShakeSlide, the application that we're working on at the moment, that will be publicly available. It will be available first to other academics because we want people to use and work with that data, but also it can potentially be used by policymakers and people outside of academia who have an interest in understanding the problems of landslides.
If there's anything you could wish for in taking this agenda forward, what would it be?
I think one of the most important things about the scientific work we do is global collaboration and collaboration between different scientists. So in building ShakeSlide, we're actually using data that's been published by other groups, other experts around the world, as well as our own data. And the power here is really in bringing this data together, bringing this knowledge together. So I think the most important tool we have is collaboration between different scientists, and anything that makes that collaboration easier, that promotes that collaboration, and that means people can more effectively work together, that's a really good thing for the science that we're doing.
And where do we see ourselves in 10 years' time?
So there's a few trends, a few things that are happening at the moment that we can kind of keep an eye on to understand where the science is going. As I said, the availability of data sets is increasing, and so we're getting 3D models of the Earth's surface, we're getting records of where landslides have happened in the past. There's some really exciting projects which are going to help landslides research. There's a project called Planet Labs, which have put hundreds of satellites in space over the last couple of years, and they are in the process of imaging the Earth, so photographing the whole surface of the Earth every single day. With systems like that, we're going to have daily monitoring of physical processes on the Earth's surface, and that's a really powerful tool for understanding when landslides happen and how they change with time. So we're going to have more data to work with. We have more and more powerful artificial intelligence, machine learning algorithms to work with and process that data. So being able to have the monitoring data and then being able to use that data to predict landslides in future. You know, we have data of where and when landslides have happened in the past. This helps us understand where and when they will happen in the future. And so the way I see things heading in this field is that our predictive capabilities are only going to increase, and the tools to help us do that are growing all the time.
We're sitting here in Ynysowen School in Aberfan with many youngsters here. How would you encourage them to participate in the study of landscapes and landslides?
I think the first thing is getting out in the landscape, getting out in the mountains. That's always been what got me thinking and what gave me ideas. So heading out to the mountains is a great place to start.
Well, it's very easy here because we're in the middle of the valley with mountainsides either side.
Absolutely, yeah. It's a perfect place to be thinking about this. And then also within school, on the academic side, the mathematics that you learn, the science that you learn, these give you the tools to then understand the landscape that you're in, understand the world around you. Computing as well, being able to write some computer code is actually an incredibly powerful tool which helps us work with, helps us to better understand the landscape through the data sets that we've got as well.
And how do universities come out into the community and develop an interest in academic life?
We actually, this summer, we had some students from local schools around the valleys actually working in Cardiff. So rather than us going out into the community, it went the other way, and we had some top A-level students did some work on this project, actually mapping landslides and analysing landslides that we're working on in China. They actually did some fantastic work, and work that's probably going to lead to publications over the next year or so. And that sort of thing is really important because it gets students into the university, but it connects us with communities in the area. And you're right, this is an important two-way process.
Obviously, this year we are commemorating the 50th anniversary of the Aberfan disaster, of which I was involved in. Do you think the modelling that's been developed would have prevented such an accident?
Looking back to Aberfan, perhaps one of the interesting things to think about is the fact that we knew at the time the dangers of landslides. Landslides from mine waste were actually quite common within the valleys, and I don't think the problem there was so much the science, it was the politics and getting people to act on that information. So as a physical scientist, I seek to understand the physical processes of how landslides happen. Perhaps one of the biggest challenges we have is putting that information into the hands of policymakers who can then make informed decisions on that basis. Even back in 2008, there was a big mine waste landslide that killed 128 people in China. So these things still happen around the world. We have the information to prevent these kinds of disasters, but it's not always acted upon.
Well, obviously we had hoped that the lessons learned from Aberfan could be picked up by governments in terms of preventing such loss of life. You know, in Aberfan there was 114 children died and 28 adults, and that's a huge loss from this community. And obviously we've seen earthquakes in Pakistan, landslides there, in Nepal and in China, with tremendous devastation that's caused by these events. And obviously there's a huge human cost to that. So your research is really trying to alleviate that loss to society. and I wish you all the best in terms of taking that research forward.
Thank you very much, Jeff.
Thank you, Rob.
Thank you.